Hello and welcome to another video in the area of networking. Today we're going to talk about reliability and redundancy, and we're going to take a closer look at some features of the newest version of Ubiquiti's operating system with their UDMs, where you can have a failover high availability unit. And so we'll take a look at how that works and a few things about how to make it the most reliable that you can make it. I have two UDM Pro Maxes that Ubiquiti was kind enough to send me to test this out. And so we're going to do a few tests on those today. But before we get to that topic, I want to talk a little bit about reliability and redundancy in general and as it relates to network gear. The first network device that I ever really had any responsibility for keeping operational was a Cisco 2501, which is a somewhat popular router in the mid and late 90s. And it was connected to a T1 circuit from MCI. So it had 1.544 megabits of bandwidth, and it provided the internet for the software company that I was working at. And at the time, that was a spectacular internet connection. And in fact, I hosted a Quake World server on that connection for many years. And it was one of the faster, lower latency Quake World servers on the West Coast. But that Cisco 2501 was configured and turned on. And then about 3.5 years later, I had to move it. And so I logged into it, and it had not been rebooted in 3.5 years, no changes. It worked flawlessly that entire time. And that was not uncommon in that particular kind of gear. They were very, very reliable, and you didn't see a lot of failures or any other problems at all. And in that same time frame, closer to the end of the time frame, I also built some equipment that went into a data center, Global Crossing data center in San Jose. And for that, I used the Cisco 6000 series chassis, which were these large chassis that had switch cards in them. And they also had a supervisor module, sort of the brains of the switch. And you could have two of them, so you had a redundant backup for that module. You could also put in a route feature card, which was a router card. And at the time, it had enough capacity to run a full internet routing table, so you could run BGP and peer with multiple providers. And we had two of those entire chassis. And all the servers were plugged into both chassis, and it was in the very high availability. And the entire time that ran, of course, not a single thing ever failed. None of the ports failed, power supplies didn't fail, the supervisors never failed. And it was highly redundant, but nothing failed. And over the last 25 years, from that period to now, I've managed lots and lots and lots of network gear, and there have been some failures. A few switches, a couple of Cisco's have kind of seen the ghost. A few power supply failures. But in the big picture, not very many. Network gear is surprisingly reliable. When I rewired my server room here at home, I had an old switch, old top-of-rack switch for IPMI that was a Cisco 2900 series switch, so a 1 gig switch that I bought in 2001, and it was in 2024 still working flawlessly, original power supplies, everything. All the ports work. And that is just typically true with network gear. It is relatively reliable equipment. It does fail, and you often have to design in assumptions for failure, because in many cases, if it fails, you lose connectivity, therefore you lose everything behind that device. But they also are, in generally speaking, highly reliable. And I mention this in part because if you're going to build either a home lab like I have here, or if you're going to do an office environment, you have options about what you could buy. You could go buy some used enterprise gear. As an example, I have a couple Cisco switches that I'm just about to retire that were used enterprise switches that you could find on eBay, as an example. And they're fantastic switches, and if you want to learn Cisco iOS, it's a great way to buy a device and learn how to configure it, certainly. And you can buy Juniper and Arista. All of the enterprise brands are pretty easy to find in switches that have been retired from data centers. And it certainly is a great way to do it, but there are some downsides of going that route. As an example, I have an Arista 7000 series, which is an old switch. And it's a 48-port 10 gig copper switch. And it's probably 12 or 13 years old. And keep in mind that 12 years ago, a 48-port 10 gig copper switch would have been fantastic. And sure enough, it is a great switch, but it draws like 500 watts at idle, and it sounds like an aircraft carrier when you turn it on. So it works, and it's old, and likely the power supplies are probably going to be the weakest link now. As an example, though, I could buy a new switch that does 10 gig copper, and it would probably draw 1/10 the power, probably, and much, much quieter. And part of that is because, 12, 13 years ago, having 48 ports of 10 gig on a fast backplane required a tremendous number of separate integrated circuits. And now that's been combined quite a bit. And so it's easier to do now than it was before. The technology's improved. And with that in mind, I've been slowly replacing those older enterprise-ish switches with Ubiquiti switches. And I mention that because one of the great things about the Ubiquiti ecosystem is, of course, the absolute ease of use. And the first Ubiquiti device that I ever had was a Ubiquiti 5 gigahertz point-to-point endpoint for wireless internet. And shortly after that, I got one of the very early edge routers, which was a cool device that they came out with that was a router that ran a Viata-based operating system that was very full-featured for effectively a home router. And then over the years, I eventually used their APs and the AP controller. And then eventually the UDM came out, and that really gave you the idea of having your firewall and the controller integrated together. And within that ecosystem now, of course, when you buy a new device, you buy a new switch, you plug it in, and then it pops up on the console, and you click adopt, and that's it. You're good to go. If you want to replace an AP, you can unplug the old one and plug in the new one and hit adopt, and it works flawlessly. All the SSIDs, everything's configured. Very, very, very low maintenance. And the thing I like about it the most is that it fundamentally allows you to spend your time using networking to solve problems, not to do networking for the sake of networking. Meaning that if you want to go and configure 4 ports as an LACP bundle to aggregate them together, you can click and do it very, very easily. And it makes it just easier to get the actual work done that you want your network to solve, as opposed to your time figuring out how to do something in your network. And kind of for that reason, I've been slowly moving other gear I have into the Ubiquiti ecosystem, because once you're in there, it's much easier to add new things and manage them all together. Adding VLANs, stuff like that, is just so easy to do. And that's probably one of the reasons why I like Ubiquiti so much. It's just an easy solution to work, even in a complex environment with many layers of switches. So with that in mind, let's take a look at the failover reliability features on the UDM series of devices and see how they work. So before we get into the software side of things, I thought I'd talk a little bit about the physical layout and the interconnections for reliability. So the concept is that you have one of these UDM Pro or Pro Maxes, and of course, it is your firewall. It is, in many cases, the router that routes between your VLANs, and it often is the controller for your Ubiquiti environment, meaning that all your devices are managed by it. And so it's sort of critical that it be up and running, not just to give you internet access, but also make it possible to manage the equipment that you have. So you have one, and of course the risk is, if for some reason it dies, then you can't really do anything. You'd have to go to the location, and even if you had a spare, you'd need to then configure that spare to be the same configuration and then move all the connections over. And so the idea of the high reliability is you can have 2 of them and have them powered on and running and configured. And if one of them fails, the other one can quite seamlessly take over and do everything it was doing before, both managing your internet connection, being your internal router and firewall rule. It also can take care of the protect infrastructure. So if you were recording cameras into the unit, it can switch that over to the new unit, plus the other Ubiquiti apps, the identity management, access management, all that stuff. So it really is a way to make your Ubiquiti environment more reliable. And the concept is pretty simple, which is that you have, of course, a unit, and you can buy one of these and configure and set it up, and then decide, hey, I want to add reliability, and you can go out and buy another one. And when you bring the other one in, you can merely plug in the WAN port into your first one, and your primary one will recognize, hey, that's another UDM Pro there. I see it. Do you want to make it a shadow device? And you hit yes, and it has a little wizard that walks you through. And you eventually end up connecting port 7 to the port 7 of the other device. And this is a little interconnection that allows the 2 UDM devices to communicate with each other and stay in sync, and more importantly, determine which one has failed and which one needs to take over. And so this link is sort of critical for how they both can operate, and only really one of them operate at a time. But the second thing you need to do is that, of course, for it to be able to take over, both of these devices need to be connected to your external internet as well as your internal network. And the general way you can do that, and there are lots of ways to think about it. In this case here, I have these yellow fiber, single mode fibers, are coming from a switch in the other room that represent my primary internet connection. And that switch has the internet coming into it, and then it has two connections coming out, going to the two 10 gig incoming ports on these two devices. And one of the cool things that the UDM Pro software does is that when it's in the standby mode, so when one device is in charge and the second one's in standby, the second one doesn't actually attempt to grab an IP address on this network, because it assumes that you likely may have a network connection that only gives you one IP address over DHCP. And so it will only ask for the one on the primary. And in the case of like normal Ethernet, you'll see that it'll leave the Ethernet port configured in lower speed and with no traffic on it. The idea being that when it's time to fail over, this device will have powered off, and then this one will then turn on that port, connect, use DHCP to get an address, and be back on the internet. And so you obviously need some way to get your internet connection from one internet device into two of these. So some cable modems might have two outputs on the back of them. And in some cases, you might need to use a small switch that allows you to connect both of these to the one cable modem or fiber modem output. And so that's one thing, is that you're going to need that way to bridge these two connections into your internet. Now, this configuration also has a backup internet. And one of the great features of the UDM is that you can have two internet connections. So you have I have the primary here, and I have this secondary here. The secondary here for me is a Starlink backup from my Comcast. And so it is perfect in the sense that if the primary link were to fail, it'll fail over and use the secondary, and that's true on both devices. But again, you do have to have two connections from your secondary internet provider. And if you only get one from them, then you need to put it into some type of switch so you get two connections. And as with the primary, it will only grab an IP address on the interface if it is in fact the one in charge, which is a great setup because it makes it such that it will work with a wide variety of potential internet connection types. And of course, that's the incoming internet side of things. Then there's your whole network. And so typically you would have, in this case, I have a switch here. This is a Pro Max switch, and I have two DAC cables going into the switch. And so both of these can see the internal network. And so this represents the internal network of all of the things on our network. And the UDM Pros can both see that network. So when one takes over, it'll merely be the one with the same IP address. It'll look inside like there was just a small blip while it flipped over to the second one. The configuration is the same on both, and it's maintained that way. So if you log into your UDM Pro and add a new camera, make a configuration change, it will synchronize automatically with the second one. So it is the same thing. So when it fails, other than the small time window from when it takes for it to notice that it's dead and then fail over, everything works flawlessly. All of the traffic will work the same. The configuration is the same. And the real question is how to handle the downstream part and the upstream part, because having to add some extra switches does itself bring in a little bit of a reliability bottleneck. And so we'll talk through a little bit about different ways to manage that bottleneck so that you get the best reliability possible. But I'll mention that overall, the real goal is to have your primary console be reliable, because it is the core of your ability to connect to the internet through the firewall, to do internal VLAN routing, and also to manage all the Ubiquiti devices. And you'll always be at the potential failure point if you only have one internet connection, as an example. But because the UDM supports multiple internet connections and both devices can use those connections, you can actually make a really reliable setup. So with that in mind, let's head over to the computer here and take a look at some configuration things and some ideas of how we can make this as reliable as possible. So let's take a look at the software side of the automated failover. And so I have the login pulled up here for my UDM Pro Max. And you can see it shows the Pro Max, and it shows the Shadow one is ready to go. It's configured and ready to take over. If you click on that, you can see that it's in that state of ready to take over. And you also can force a sync if you make a setting change and you want to do it immediately. It'll do it automatically over time, but if you want to force a sync, you can. but it's in the ready to take over stage. And so I have a little ping going here, just pinging out to the internet. And so if I walk over here and unplug the main firewall, you will see over here that it just dropped. And there it is. The second one has taken over. And so now we're back on the internet. And if you were doing something, you would hardly notice that you had switched over on, you can't see it, but on the front panel, it says the second one's taken over. Okay, and here we are with the Shadow Gateway. It now shows it being active. And it's in control now. And it mentions, by the way, that changes made during a failover overwritten, because when the primary takes over, it's just going to use its current config, which is perfectly fine. You can see the pings popping up here. And we're going to plug in the UDM Pro Max, the first one, and let it start booting up. And so now it will be as if you had fixed the first one or replaced it. And so it's now booting up again. And so we'll let it boot up, and we'll see a really small blip here when it boots up and it switches back over to the primary. And now we're back on the primary. And in fact, we didn't even get a drop in the ping. The secondary device says that it's ready to take over, so we're back on the primary. So let's reconnect and log back into the primary. And here we are back on the primary, and you can see the primary's in charge and the Shadow Gateway is ready to take over again. So extremely seamless, both in the failover to the backup and the recovery back to the original one. So it works pretty flawlessly. It just works. So fantastic. But let's talk about a couple things that are probably interesting in this space, and that is to do with how you wire things for the maximum reliability. And we'll start with this idea that you're going to have some type of access device for your internet. It could be a cable modem, or it could be like a fiber Fios endpoint of some kind, something that connects you to the outside world. And usually this will have a port on it of some kind, an RJ45 Ethernet port, and that's generally plugged into a port on your UDM device. And so the idea is, of course, you have two of these, and you would then, if this cable modem or endpoint has an extra port on it, you could plug that extra port into your other UDM device. And of course, this switch here represents your internal network, where you have things like your APs and maybe other switches, whatever. And of course, each of these UDMs connect to your switching stack. And so now you have it set up such that if one of these fails, the second one can take over, and it has connections to both your internet as well as your internal network, and you get the seamless failover. If, for instance, you don't actually have multiple ports here, then one option is you can put a little maybe 4-port switch here and have the cable modem come in to one of those ports on the switch, and then have another port going out to this firewall, and then another port here that goes to this link here and to here. And so the idea is that you have this little switch that's in the path, and there's one connection here, but then there's an output here and an output here. And that will allow you to have both of these two plugged in. And of course, the UDM is smart in that it doesn't actually activate this connection and try to get an IP if it isn't active. So you'll only have one of these at a time trying to connect to your device. And you can even do MAC copying or MAC changing where they both have the same MAC address in case your device here is MAC address locked. So it's an easy way to do it. And then you have this little switch here for that. Now, a couple things to keep in mind is that now you might describe your cable modem and this little switch in the same failure domain. And what I mean is that if either one fails, then your internet fails. Because if this switch fails, then both these links are going to go down. So this is this gets combined into a single point of failure. And that's okay. That's the nature of having a single internet connection. Now, if you decided to get another internet connection, let's say you have a connection here that's, let's say it's Starlink, and it's your backup connection, you could have a little small switch here that it plugs into, and then have from this switch plugged into the secondary internet input of both of these UDMs. And of course, the UDM supports having more than one internet connection. It supports two, and it will automatically fail over to the second one when the first one's down. And in this failover mode, even when you're in the failover, that can also fail over to the other internet connection. And so since these are different switches, each one of these have their own little failure domain. And so in theory, if something bad happens up here, then this internet connection can take over. And that's somewhat valuable, especially if you have a failure that loses both this switch and one of the UDMs, and it fails over, and you still want to be able to log in to configure it, especially if you're working remotely. Then having this backup internet connection is a fantastic way to do it. And then, of course, this connects down into your main switch. And in this model, the idea is that you have redundancy at the level of your UDM controller. So if one of these goes away, you have a backup, which gives you the ability to manage the situation. A great example is that you lose one of these, and you can then still connect in and maybe ship someone a new one to reinstall and configure, and then bring it back up again. And so it really gives you that remote management capability, even in the case of failure. A couple other minor things, when you do this configuration, you could have your internet connection, instead of buying two little switches, you could partition off part of one of your internal switches into their own individual VLANs and have these VLANs not be isolated from other VLANs. And you could have your internet come in and go into one of these VLANs, and then have the output of these VLANs go as the internet connection to both of the machines. And that will work fine. I mean, these can be isolated. The only downside is if you lose this switch, then you lose both the internet connections and your ability to connect into the UDMs to manage things. And so it isn't as ideal. If you're managing entirely locally, it can work fine because you can always plug a machine into one of the firewalls if you want to configure it. But if you're remote, it would be sort of non-ideal to do it. You could look at having two complete internal networks, and having maybe one of the extra ports here connect into a second set of switches, and maybe set it up so that maybe some of your APs are off this switch and some of your APs are off this switch, so that if an internal switch fails, maybe half of your APs go offline. It's always a possibility to make it a little more reliable or a little more fault tolerant. But the main goal of the UDM Pro failover is, if you lose the UDM itself, the failover is very quick, instantaneous, and allows you to still kind of manage the network. So if you're going to do this design, think about how you're going to get multiple connections from your internet box, whether it be through a little switch or not. I think it's always good to consider having an alternate internet connection. Sometimes this can be even like an LTE modem. That way, if you lose your primary internet, you have a backup that still allows you to get in to do management. And so it's something to consider. But overall, you can see that when it's actually configured, it works flawlessly. It's really, really easy to use. And I think it's a great feature to have if you want to make your network a little more reliable. So keep that in mind. And on the next video, we're going to do some digging into some really cool performance measurement techniques for sort of measuring the performance of many components of your network. So thanks for now.